Hello everyone. Today we're going to learn one of the most fundamental and fascinating topics in physics, Newton's laws of motion. These three laws explain why objects move, why they stop, and how forces affect everything around us, from a moving car to a flying rocket. Let's start with the first law of motion. Newton's first law states that an object remains at rest or continues moving with constant velocity in a straight line unless acted upon by an external, unbalanced force. What does that mean in simple words? It means objects do not change their state of motion on their own. A stationary object will stay still unless something pushes or pulls it. A moving object will keep moving at the same speed in the same direction unless a force acts on it. This tendency of objects to resist changes in their motion is called inertia. The greater the mass of an object, the greater its inertia. For example, it is much harder to push a truck than a bicycle because the truck has more mass and therefore more inertia. A common real-life example of Newton's first law is what happens when a bus stops suddenly. Passengers move forward because their bodies want to continue moving due to inertia. This is also why seatbelts are so important. They provide the force needed to stop your body safely. Now let's move to Newton's second law of motion. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This law is represented by the famous equation F equals m times a, where F is force, m is mass, and a is acceleration. This means that if you apply more force to an object, it accelerates more. But if the object has more mass, it accelerates less for the same force. Let's understand this with an example. Suppose you push an empty shopping cart and a loaded shopping cart with the same force. Which one moves faster? The empty one, because it has less mass and therefore accelerates more easily. Here's a numerical example. If a force of 20 newtons acts on an object with mass 4 kilograms, then acceleration equals force divided by mass. Acceleration equals 20 divided by 4, which gives 5 meters per second squared. That means the object speeds up by 5 meters per second every second. Newton's second law helps us understand why heavier vehicles need bigger engines and why lighter sports cars accelerate faster. Now let's discuss Newton's third law of motion. Newton's third law states that for every action, there is an equal and opposite reaction. This means whenever one object exerts a force on another object, the second object exerts an equal force back in the opposite direction. These forces are always equal in magnitude and opposite in direction. A great example is walking. When you walk, your foot pushes backward against the ground. In response, the ground pushes you forward with an equal and opposite force. That forward push is what moves you. Another example is swimming. A swimmer pushes water backward, and the water pushes the swimmer forward. Rockets also work on Newton's third law. The rocket pushes hot gases downward at high speed, and the gases push the rocket upward with equal force. Even when you fire a gun, the bullet moves forward, and the gun recoils backward because of this law. Now let's quickly summarize all three laws. Newton's first law explains inertia, the tendency of objects to resist changes in motion. Newton's second law explains how force, mass, and acceleration are related using F equals ma. Newton's third law explains that forces always come in pairs, equal and opposite action and reaction. These laws are not just theoretical. They explain countless everyday situations around us, from driving cars and playing sports to launching satellites into space. Before we finish, here are some common mistakes students make. First, many students confuse mass with weight. Mass is the amount of matter in an object, while weight is the force due to gravity acting on that mass. Second, students often forget that in Newton's second law, we use net force, meaning the total unbalanced force acting on the object. Third, many think action and reaction forces cancel each other. They do not cancel because they act on different objects. Understanding Newton's laws is essential because they form the foundation of mechanics and many advanced physics topics. So whenever you see motion around you, remember, Newton's laws are at work. And keep exploring the amazing world of physics